So, welcome to another edition of Seen and Solved from Hubbard-Hall. I'm Tim Pennington, editor of finishingandcoding.com. And today we're going to be speaking with Joshua McClellan, an application engineer in the aqueous cleaning division at Hubbard-Hall.
This is Seen and Solved with host Tim Pennington, brought to you by Hubbard-Hall. Better results, less chemistry.
Joshua, thank you for joining us. Tell us where you're standing right now.
Right now, I'm currently in Inman, South Carolina, where it's one of our facilities. And so, yeah.
It's one of your labs, right? That's where you guys do some test labs and everything? Gotcha. I can hear the boilers burning and the beakers and everything and the clinking in the background, I'm thinking.
It's where all the magic happens.
The magic, that's what they say. That's right. Speaking of magic, we're going to talk about today, going to be Cleaning 101, which seems like a very simple, basic topic, but I know that parts cleaning sometimes is perplexing to finishers and coders. But this is a good way to start and to kind of give them an idea of what are some of the basics that they should be following. Hopefully they'll follow them and repeat those. But first, I want to talk about you a little bit. Let's all talk about you. Tell us a little bit about your background, your training, and what has led you to where you are today.
Okay.
And why you love cleaning so much. Why you love cleaning. I know you do.
Yeah. So I have a chemistry degree, also with a master's in business. I've been in the chemical world for about 15 years. I kind of straddle from the sales side in the technical realm. And basically, I learned that I like more of the technical part, but also a smidge bit of the selling. And so for my job now, I go out and I look at the total process from instrumentation that they have, the chemistry, and the desired part that they need. And so for me, I go in and I ask them a series of questions, trying to figure out what type of metal, type of soil, what type of coating that they're going to put on next, and just try to fill in all the missing pieces to the puzzle that they are missing to get that desired clean part that they're wanting. Right. And so that's kind of what I do. Just
what percentage of your time are you actually in the shops or in a facility?
So just depending. So almost 50-50.
Gotcha. Okay. So go ahead. You said just recently.
I go out and I assess the situation. I come back and work my superpowers and get these parts clean. And I go right back out. I'm like, hey, I've done it again.
You're the cleaning detective. That's what it is. It's like a crime scene. You've been there with that. Let's talk about this real quick. So so people call, right? They call in. Maybe it's a new customer. Let's talk about a new customer. New customer will call in and say, I've got this problem. We don't know how to figure it out. Is that when you basically go out and visit them and put eyes on the process, or what is it that you do?
Yes, for the most part, yeah. We kind of look at the how big that opportunity is, because sometimes people will call in and they have like a 5-gallon tank. Like, we don't need to go get that. But when it's like a 1,000-gallon tank, we'll go and assess their situation. We'll go there. We'll talk to them about what's going on, like what they're currently doing, and like what are they pain points or whatever. Once they tell us all that, then we from there we kind of say, hey, here are the things that are going wrong and what we can fix. But we always try to stay in the realm of what they're capable of, because sometimes some people do need new tanks to kind of make the process work, but they can afford a new tank. So we still try to work in what I guess the capital that they have to support this project. And so once we get all that information, we figure out what type of chemistry that we need to clean the parts and bring it back to them and say, hey, from what we have, this is what I recommend you to do to get the desired part that you need.
Right. And I'm assuming too, like I said, you've got your lab there, and then a lot of what you do, you're working with your coworkers and team. Nobody expects you to solve every problem in the world, Joshua. So I'm sure you go back and have the lab look at some things, or and talk to some other people, and really it's kind of a collaborative effort to solve what the problem is. Yeah,
for sure. I mean, Batman had Robin, so you can't do it by yourself.
Right, exactly with that. And then, so when you're not in the field, are you just sort of working with existing customers on, if they've got issues, or what else are you doing with that?
So working with existing customers, always helping the sales rep out. They always have questions. We also have a portal that our current customers or new customers can go to and say, hey, I'm having this pain point and I need help. So I'll just, I'll get that call. I either email them back or call them. It just depends on how they want to be communicated with. And I typically try to call them, especially if it's a new customer or a customer that I know, like, hey, this is going to take a long time and I want to write a dissertation email. I'd rather just call you and kind of like have that back and forth conversation, make sure that you didn't leave out any important information. Because sometimes people tend to leave out the little details, which end up being the big details.
Right.
I was just with a customer and we're only cleaning brass. And I was like, oh, yeah, I got the perfect cleaner for brass. And then I get there, he was like, oh, it messed up my aluminum parts. You didn't say
aluminum.
You said brass. So I kind of used the very, the right cleaner for the brass and not a cleaner for the aluminum. So I had to go back into the lab. But before I went back, I was like, what are all the metals that would be in this bath?
Right. So it often is good to go there, right? To do it, kind of scope it out, go from front to bottom and see everything that they're, trust but verify, as Reagan said, right?
Correct. Because sometimes, again, I get it. Like they'll use aluminum. He said he only used aluminum maybe once a month or whatever, versus aluminum. Versus the brass he was cleaning every single day. So I get it. Right. Like he's just mystifying a little idea.
Right.
Important facts.
All right. So today our topic is cleaning 101, which seems like a simple and a basic topic, but I know that parts cleaning process is the bane of every finisher and coater because it often leads to problems if they don't do it right. And actually, it's a fairly complex. It can be a fairly complex process if you're not following proper procedures and such. Do you get that sense when you're with some of your customers out there that they sometimes struggle just to get the 101 part down?
Oh yes, all the time. They always want that nice shiny part, but they forget like the main way to get to that nice shiny part is cleaning, and cleaning is always typically one of the first steps in helping create that nice shiny part for us consumers. We go in the store and wants to pick up like a nice piece of like a shiny, nice, a brand new shiny car. Like you don't want to go to a car dealership with all the lumps and bumps in the hood, and it's not very desirable. So therefore, if you can get that part clean before it gets converted, you did your job.
Did your job right. And so, then you're going to get either corrosion or parts sometimes get parts failure, which can be very bad if it's a critical part with that. But like I said, most conferences I've gone to, that has been the problem that a lot of people talk about. But it's almost like a second thought sometimes of people who don't, it's like the last thing they think about of why a problem occurred, and they'll be like, oh darn, scratching their head, why didn't we think about that? Where it really, and I've had a lot of experience writing about this. It's always seems to be the most critical first step. So, but let me ask you, I guess. There's a lot of, and maybe this is the problem. There's a lot of variables that people have when they're cleaning parts. A lot of things can go wrong. A lot of things can go right, but more often, if they're not paying attention, a lot of things can go wrong. So let's talk about the variables. What are some things that people need to have a good consideration of when they're actually in the cleaning process?
Well, there are several variables. I'll name them all. The concentration, time, temperature, agitation, the type of soil, and rinsing, and all of them play a different role in the cleaning process, depending on especially like if you're gonna do silk cleaning versus spray cleaning. So, for instance, like for concentration, I mean, that's the amount of cleaning you actually put in your bath to actually clean the part. And sometimes you can put too much cleaning, which will then actually can affect the part being clean. So. Actually knowing what concentration you really need, it's actually a big variable in this process. Also with time, sometimes it might take 2 minutes to clean your product. Sometimes it might take over 3 hours, just depending on that process. But you got to know, because if you over clean, sometimes you can have a bigger problem because it's too clean. Then it might cause like rusting or something. So like just kind of knowing the time frame to clean that certain part. Also with temperature, sometimes increase of temperature will help like remove some of the dirt, and sometimes if the temperature is too high, it might actually tarnish the part, depending on what type of metal you have. For agitation, sometimes you do need a little bit of like help from the machine, like ultrasonics, some impingement to kind of like help beat up the the oil or the grease that's on the part. So like just kind of depending on what type of soil you have. And again, like I said, soils, knowing what soil you actually have on the part, like is it water soluble or water insoluble? So that helps us figure out what type of chemistry we need to help remove that chemistry. Because, we have to, the surfactants that we're using in our formulated products have to lift and remove that oil. And one of the biggest things that I see all the time is rinsing. People think rinsing is like not as important, but like rinsing help, basically stop the contamination from the cleaner tank going to
You got to get it off.
So sometimes I tell people like dump your rinse as much as possible or have multiple rinses. So if you have multiple rinsing, tanks, you're on the right track for again good parts. So those are some of the variables that I think is very, very important when you're thinking about your cleaning process in the variables.
Right. And I found that most times with these variables, a lot of shops that are doing the cleaning are guessing because they don't know what, like you said, what type of contamination is on that, what the cutting fluid was or whatever it was when this part was machined. There may be a rust inhibitor put on there or, and they may ask, and then, the next shipment they get, something's changed and they have to start over again. So that seems to be the one, is to figure out as much as they can what's on these parts, what's on it that we got to take off, which a lot of times they're never going to get an answer to that, I don't believe.
No, not sometimes. Some of their suppliers don't always tell them what type of chemistry that's in the grease or the oil or the soil. They just know like, hey, this is going to help you extrude your part to the shape that you want. And they just go for it. And sometimes people go off for price, and sometimes people just go off like what traditionally has been used in the market. And so as my job is trying to make sure that I give them the right cleaner for their whole process and not just that cleaning tank. I look at the total process and not just like one thing in their process.
What's always surprised me is when I go into a shop or, I'll joke sometimes when they show me their cleaning process and I'll say, who's your director of cleaning? And there's nobody, right? Yes. There's nobody that has taken that job, as complex as it can be. There's nobody that's taken that job on and own that. It just seems like it's always the third part of somebody else's job, right? It's the third on their job description is you're in charge of the cleaning. Okay, that's what they do. And
sometimes that person can actually be us. Sometimes sort of smaller companies, we are a cleaner of director. Like they count on us to have that knowledge, that expert to kind of make sure that their process don't fail and that they can keep making good parts as well. So like sometimes, we are a jack of all trades sometimes.
You're a phone call away. That's what it is. Yeah. So, you talked about those variables. And so let's talk about, controlling the parameters of the cleaner tank. Like you mentioned, sometimes people, they clean too long or they use too much chemistry and everything. And, I often hear about drift where, the first shift does this and the second shift, well, why not? Let's add a little bit more and everything. So what about controlling those parameters? How do shops, what's the best practices they could have to really controlling those parameters of the cleaning tank?
So in the cleaning tank, one of the biggest things that we try to focus on is the concentration, especially because again, that's one of the ways where how much chemistry that you're putting in your tank. And if we say, hey, this tank needs to be at a 5% concentration through the whole period to get the best part. So one of the ways that you can actually calculate or I guess monitor concentrations do via titration and also conductivity. And sometimes you just take these things and have them already in your equipment. So it can self-monitor itself versus you keep trying to do your own test every hour or more. Mm-hmm. So that's for us is we say if you can, have a meter to kind of follow if the concentration is going to drift or not drift. That is one way. And another simpler way that you can also do, so sometimes when you have formulated type of product where you can, the acidity of your product. So if you have a very say if you're phosphating, when you're phosphating. So when you're in the phosphate tank, it's basically an acid base. And then sometimes before a phosphate, you have a caustic-based cleaner. And if you keep dragging that caustic-based cleaner into your phosphate tank, you basically going to kill that tank. And one of the quickest way is to look at the pH. So pH is very quick and dirty. You just putting your little probe and see that number flash out. That number is, honestly, if it's above a 7, you're way off, but it should be around like 3 or 4 or 5. But for the most part, like, yeah, so looking at the concentration and also checking the pH. And for the concentration, make sure you have a conductivity meter or some way that you can titrate your bath.
Right. Well, you know, it's funny you mentioned all that. Is there one simple method that you would suggest to somebody to ensure this process works? Is there a trick of the trade you would tell somebody, or is there a simpler method that you would suggest to them?
I think the simplest way would be having a conductivity meter like already in your equipment. That's safe, and you can have it like once your bath drifts away from that concentration, it should be a meter that actually add more chemistry back into the tank to keep that concentration at the desired concentration that you have set already. So that for me is really the simplest and safest way that keeps everybody's hands like clean and safe.
Right. The big question is how often do you see that when you're in the shops and you're called in for how often do you see that they have that type of equipment and they're doing it that way?
All the time, which is great. Everybody has that, and it's very easy to go back and like look at their log to see like, hey, your concentration was dripping here to here this many times. You've been having to add so much chemistry in, so that means either it just helps us like it's a better story that's been told that we can't see until we come in there. And so that for us, that's so much easier to have all that factual data versus some of the, oh yeah, I think it was this concentration or I dumped more of this in there. Right. And so it's very hard for you to be like, okay, how much did you dump in? And they don't know. So this way it's like a true value versus an assumption or just a question, answer where it's just like, I think I did this.
Right. Exactly. Right. So have you ever asked somebody in a shop about that and they just flat out lied to you? Somebody who thinks they're going to get in trouble, they're not going to tell you the truth. I mean, I'm sure when you get into that, like I said, you get very many hands. You're talking about, people, they make mistakes. They don't want to fess up to it. I'm sure that when you're trying to get in and digest and figure out what exactly has happened here, I'm sure that comes up where people are like, yeah, they don't want to admit that they didn't take a reading or they,
My answer to that question is snitches get stitches. So
gotcha. There you go.
I'm going to say I've seen it, but I won't say how many times and who did it. But I've always said, just tell me the truth. I'll help you.
Just tell me the truth. That's all you got to do, and we won't hurt you.
I'll figure out a story that will tell your boss what happened. Right. But you're fine.
Right. There's the logs and there's the truth. That's true. Yeah. So, we talked about a lot of variables, right? But, not all parts are made the same. You've got different part geometry. You've got downholes. You've got things that really, again, they need to take into consideration those geometry features when they're setting up their process, correct?
Yes. Because like you said, the geometry, like those blind spots, sometimes the aqueous cleaners, they get like caught up in those little nicks and crannies and it just cannot get pulled out from just, even after you like clean it, sometimes because basically that surface tension of water, it doesn't overcome the surface tension of the surfactant to actually get pushed out of the actually part. So therefore, sometimes like aqueous cleaning cannot, sometimes you might need to do solvent cleaning to kind of help overachieve that hardship that you have from trying to use aqueous cleaning. And sometimes if that aqueous cleaning dries into the part, it basically it can start to rust the part. So, I mean, and then no bueno.
Right. Yeah, exactly. And, one of the things too, I hear with aluminum anodizers and finishers, if they haven't got the cleaning process really tuned in, there can be some etching on the surface, which again is a bigger problem. So talk about aluminum, and cleaning aluminum without etching it. What does that take?
So typically you want to use like a very mild to like neutral cleaner. So like pH from 7 up to about 10. If you can stay around that would help you clean your part, make them nice and shiny without etching. Because like anything above the the 10 or maybe around like 13 or as low as like 2 or 5, they're definitely going to etch the part, and you can't overcome etching. Once it's etched, it is etched. So
You are
therefore,
done. Right.
yeah, so there's no going back. So if
Back.
even if it
Right.
had a very like mild cleaner from like say pH 7 to about 10,
Mhm.
you should be fine. Or sometimes even having a cleaner have an enhancement of a surfactant package also helps protect the surface of the aluminum while being clean.
Right. Right. Yeah. There is, like you said, no going back. And then you need to, some of these parts can be very, if they're, aerospace parts, it can be a problem. I mean,
Oh yeah.
you're talking big money with that. So that's why I always tell people that's a big investment, is to make sure you got your cleaning right, or else you're going to ruin a lot of good parts with that. But
Oh yeah, because
um,
we have these long, big, machines, and like they'll
right,
process thousands or hundreds of thousand parts. Oh, these parts are etched, and there's nothing
right,
that they can do about it.
right. It's a big uh-oh. So,
Yep.
so it's funny is that this was when I first started years ago. When people would talk about cleaning, and I go to these things, I'd always say, "Well, how do you know it's clean? How do you know? You put it in a tank and you've done all the cleaning and you rinsed it and everything. That doesn't mean it's clean, right? I mean, and I know in Europe they have put a standard in that things have to be microscoped and everything, but." So what methods are used to make sure that the part is cleaned as well enough so then it can go to the next step, which is a possible coating with that.
So some of the things that we look at in the field is like we do like a water break test. We
Hmm.
do either do a white glove test, and sometimes like in the lab, I'll use a UV light, just depending on what type of soil that's on the part that it will fluoresce. For the water break test, if the water beads onto the part, that's basically saying, oh yeah, the part's clean. The only thing what you got to look for when you're looking for a water break test, you can't have a soap-based cleaner, because you have a
Mm,
soap-based cleaner, it's obviously it's going to bead on the part. So just being
right.
aware of what type of cleaning you have if you're going to do a water break test. But for a white glove test, it's very simple. Just put on the white glove and you just wipe the part. If the white glove is dirty, your part still is dirty. So very
That
simple.
I just have to say I'm not an expert, but that doesn't seem very scientific. But I guess it works for a lot of people. I mean, that's what you're
You'll
just
be surprised some of the techniques people use on their own that they say this is
right,
why these parts are clean. And
right,
I just shake my head and I say I'll still use my way and we'll compare it to your way. Hopefully we have the same answer each time. So
right,
that's what I try I try to do.
right. Trying to do it with that. It's funny. Every finisher, every coder, they want to extend their tank life, right? They want to get as long as they possibly can. And there's no magic, light that goes off and says, you need to change this out. But what are some ideas or suggestions you would have for shops about ways that they can extend their cleaner tanks, that
Well,
they can get more life out of them?
Well, depending on what type of cleaning system you have. So if you have an
Right.
emulsifier type cleaner versus a split oil. So basically, I would say like for things that we try to get people to put in their tanks are like an oil separator or a oil coalescer or a skimmer.
Hmm.
And all those things basically help, like in reality, separate the cleaner that's been the cleaner from the oil, so you can reuse the cleaner again.
Right.
Um, we do have some a new technology like that we use here is membrane filtration, and that's
Hmm.
typically, but it's only for emulsifier type cleaners.
Right.
So like we're still trying to, I guess, help people in the field to help like extend their bath tanks if it's an emulsifier cleaner.
Right. Gotcha. So you all have a lot of cleaning products, right? You have lots of, and then you actually have variations of those products as well and everything.
Yeah.
So when you go into a shop, and you're asked to kind of, spec out a new cleaning process, what goes through your list? How do you pick what Hubbard-Hall product you have that you're going to integrate into their system? How do you choose the best method for that?
So basically, I ask, what are the alloys and metals that you have? And I
Hmm.
ask that question several times because sometimes people say, oh, I'm only using steel. And then you find they're using carbon steel and they're using aluminum as well, but they don't use those metals as much. But those things are very, very important because, for cleaning steel, you can use
Hmm.
a caustic based cleaner and be just fine. But when you try and clean steel and carbon steel and aluminum and zinc, you got to think about it. You take a step back and you need something with a lower a more milder pH versus a
Mhm.
pH of like 13 or 14. And so we try to figure out what type of metal, what type of soil that they have. We also look at the type of equipment that they have, because sometimes, if
Mhm.
they're soaking
Right.
versus spray, you don't want to give them a very high foaming cleaner and that it's going to explode out of the tank. We
Right.
also look at what type of wastewater system treatment that they have and what kind of chemistries that they are trying to stay clear from, because some people have different requirements of how they treat their waste. Some people get their waste hauled out every day. Some people have a waste treatment system and they kind of treat the waste on site. So we look at all those different variables, and then from there we try to take all that funnel of all the information, try to funnel it down to a nice perfect cleaner that we think is best. And
Right.
so once we do that, we either tell them, hey, just put it in a tank and we know it works, or we're like, hey, send us
Mhm.
some parts, we can verify it for you if you like. But typically, like, put it in a tank, we know it'll work.
We know to work. You've seen those enough to know,
Oh
right?
yes.
Your experience
Oh
with
yes.
that. Definitely.
We said, me and my boss Mike, we said we're gonna make these T-shirts and say, put it in the tank.
Put it in the tank. Just give it a
Put it in the
shot.
tank.
See what's good. Good things may happen if that's
Yeah.
what happens there. All right.
Correct.
As a takeaway, we've talked about a lot of things. Let's talk about a takeaway, since this is called Seen and Solved. We have to put the solved part in there. So as a takeaway from today, what are some suggestions, some thoughts you would give finishers and coaters who are, that they should always keep in mind, when it comes to cleaning their parts and running their process? What are some thoughts? I guess you would talk about, look at the variables, right?
Yeah. Yeah. Again, look at the variables and knowing all the metals that you are running through your system, especially if you don't want to change your cleaners from this part from that part. So if you are trying to use the same cleaner for several different metals, that's fine. We have multi-metal cleaners. So therefore, like we have options for that, but we just have to know, I guess I'll put the truth of what you're actually cleaning. And also, let us know, like, what is your desired look and go that you're trying to accomplish. So therefore, if you do want an etch part, we can make sure we give you a clean that's going to etch the part a little bit, so that would enhance the adhesion to the next conversion coating. But like, I guess the biggest thing that I would tell people is, like, let us know exactly what you're looking for, and we can partner with you and get you to that desired part that you're looking for.
Right. And if there's any doubt, just put it in the tank.
Put it in the
Put it in the tank, see how it goes. All right. Joshua, thank you for joining us today and giving us all that information. Cleaning 101. I guess soon we'll be doing cleaning 200, which is we'll figure that out when we get there. But thanks for joining us today. Appreciate it.
Anytime, Tim. Anytime. It was great talking with you. And like I said, I love what I do. And so, like, if anybody have any questions, please call me or Mike or anybody at Hubbard-Hall, and we'll get you the answer that you need.
There you go. All right. You can also visit Hubbard-Hall.com to get more information about some of the products. And you got some case studies on there. So, all right. Thank you very much. Appreciate it.
You're welcome.
Seen and Solved is brought to you by Hubbard-Hall. Better results, less chemistry. For more podcasts, go to Hubbard-Hall.com or wherever you get your podcasts.